Lindsay's going to talk to us about zombie pancakes.
G'day everyone. You can all hear me up the back okay? Yep. Fantastic. Right, my name's Lindsay. I'm talking about Flapjack and how we've rebooted the project. So my name's Lindsay. I actually gave a presentation at LCA 2010 in Wellington about Flapjack. This is sort of a bit of a retrospective about what's happened for the last sort of year or two and where we're going right now with the project. So yeah, like I said, I created Flapjack and I abandoned Flapjack. I'm very sorry to say this. And in fact, I have actually created a monster now. All right, what happened? How did I create this monster? Well, the biggest problem for Flapjack development was that I was the bottleneck. This is bad, you know, it's something that you don't ever want to be in an open source project, but it's unfortunately far too easy a thing to do. There were a bunch of small contributions from people other than me, but I did a pretty poor job of actually keeping those maintained. So, you know, lots of pull requests that were banking up on GitHub. And I had a couple of other projects as well. So Visage, which I've talked about a couple of times, and then I had 2 children, which I definitely consider to be projects, although not open source. So Flapjack, rest in peace, 2010. Zombification, how has it come about? What is Flapjack right now? So Flapjack is actually being used in production at the place where I work right now. It is fully 100% open source. However, there is sponsored development, and that means that there's 1 to 3 full-time engineers that are actually working on it at any given time. And obviously not today, because it's Australia Day, but generally we have at least 1 to 3 people that are working on it. So talk is cheap. Let's actually have a look at a demo of what it is. Now, I wrote these slides before my laptop developed a hardware fault, so I've been busily trying to get the demo working on, yeah, it's not even there yet. So yeah, talk is cheap. I'm just going to keep going on and just act as though you've seen a demo and it's fantastic. I'll try and get up a demo a bit later and show you guys, but yeah, really sorry about that. New focus. Okay, so Flapjack has changed very significantly from what it was originally trying to do. Previously it was about check execution, and now it's moving more to sort of event processing. And what do I actually mean by event processing? Well, we implement the concept of filters, so it's basically dealing with the stream of monitoring events that have been generated by another monitoring system, a check execution engine. We're applying a bunch of filters to those to work out whether we should or shouldn't notify somebody. And we do that through the concept of delays. So we assume that there's a constant stream of events that's coming through the system. And basically you go, okay, if this particular event here, and like in a really simple model, if this particular event here represents a failure, and this thing has been failing for longer than 20 seconds, then we need to actually notify somebody. So yeah, the whole thing using delays and feedback loops and that sort of thing. We also ship a little thing with it called UberTet, which stands for the out-of-band end-to-end test. So the awesome thing about it means that there's actually always monitoring checks that are being executed, and we're checking the whole life cycle end to end to make sure that the event processing is actually happening. And the real goal, what we're trying to move towards now, is focusing on emergent behavior. So looking at how the relationships between different monitoring checks and those systems that those monitoring checks are checking, trying to identify more quickly when you have large failures of, you know, thousands of checks failing simultaneously, not bombarding the person that's on call with 1,000 individual notifications. So yeah, fundamentally, no check execution left in Flapjack. I consider this to be a solved problem by Nagios or Sensu. Both do a very good job of that. But the idea is that we basically utilize existing open source infrastructure to do the check execution and the check configuration, and it's something that you can, Flapjack could become something you can deploy in parallel to the side, which is doing all your event processing and notification. It's Redis backed, so Redis is absolutely fantastic for exactly this particular type of job. I'm not sure if anyone's seen the blog post from Ari Pina from the middle of December, talking about how he's building a next generation monitoring system on top of Redis. It goes into what we're doing in Flapjack. I'll talk about that a little bit later. It's also fully benchmarked. Benchmarking is a really core part of what we're doing. We want to make sure that it's fast, reliable, works, all that jazz, and very, very well tested as well. So you're probably asking, why would I use Flapjack? Well, Flapjack fundamentally is a platform. We're not designing it to be just like a standalone tool. We're trying to build it in such a way that you can take it, put it into your, into your environment, and build and adapt on top of it on a site-specific basis. This whole thing of infrastructure code as give me an API or give me death. We're absolutely embracing that 100%. So right now there are APIs for adding context to the system, scheduling maintenance, entity history as well. So we use slightly different terminology for services and checks in the Nagios parlance. We call them entities and hosts. Sorry, services and hosts and services, and we call them entities and checks. Sorry. Yeah, and there's baked in SLA reporting that's there as well, and that's actually consumable with a little library that we've got that sits off to the side. I'll talk about that in a second. So plentiful notification options. Just nobody, if the tree falls in the forest and nobody's there to hear it, then who cares? So uni and bidirectional gateways. We have this concept of a notification gateway, which is after it's gone through the series of filters in the Flapjack, what we call the Flapjack executive, it gets passed to a notification gateway, which basically works out how to actually contact the person. So we've got unidirectional gateways for email and SMS, so that basically means that it's like a read-only notification, it sends stuff out, and that's it. But then we have bidirectional gateways as well, so XMPP, which Jabber, it's fantastic, you've got a company chat room or something like that, and PagerDuty. I'm not sure if anyone here, actually, brief show of hands, who here is using PagerDuty at all? Okay, cool, small number of people. It's definitely worth checking out. Basically, it lets you respond to monitoring alerts from your phone. It's a software as a service thing. But the cool thing about it is that the one thing that Flapjack does that no other monitoring system that I'm aware of at the moment does is that if you ACK or escalate a page through PagerDuty from your phone, it actually transfers all the way back down to Flapjack itself. Most other systems, you've got to do a double ACK. You've got to ACK once in PagerDuty and then ACK again on your monitoring system. It's designed to be multi-tenant from the ground up. So this is what I was talking before about it being a platform, something that you can easily consume and put into your environment. Again, hey, give me an API, give me death. We've got a library that we ship with it. It's a separate project called Flapjack Diner. It does all the smart things for consuming the API. It's a standalone client. And we're actually using this in production with a bunch of our self-service systems. And the main idea with what we're trying to do with making it multi-tenant and a platform is we're trying to push a lot of the complexity to the edge. Example of complexity is authorization, right? We have a very simple authentication model, but the idea is that with Flapjack Diner, you would be able to write your own interfaces around it to do your own access controls and that sort of thing on a per-site basis. And we make it very, very easy to do that. All the code's very well tested, very well documented. So fundamentally it means the Flapjack works very, very well standalone, but it's really, really good if you're in a service provider environment as well. Excellent documentation. So if you check out the Flapjack repository, it's now in a separate GitHub organization called Flapjack. Sound like I'm a New Zealander. So yeah, if you check out the code here, the doc directory there actually just points to the Flapjack wiki. And there's tons of documentation about developing the data structures that we use behind the scenes. Very, very solid documentation on that. We spend a lot of time specking that up, so it's really easy to come and write your own integrations on top of it. Stuff for importing data as well, and just for debugging and using it in production. Lots of troubleshooting documentation, because like I said, we are using this in production. We really deeply, thoroughly care about documentation. In fact, so much if the documentation is bad and you don't understand how it works, then we consider that as a bug and go and file a bug. So yeah, to summarize, these are the reasons why you should really care about it. It's a platform, fantastic notifications, multi-tenant, and documentation. So where's Flapjack headed? Why are we doing all this work? So there are two features that are on the very near horizon that we're working on right at the moment, and all this development is public. We're not in the business of developing stuff behind closed doors and then foisting it upon the community that's built around Flapjack. We're making sure that we're doing all the development in public. So the two things that I'm really passionate and excited about right now are loading and notification rules. So basically, we're trying to come up with a high-level way that you can define how people can register interest in particular things based on tags. So as well. So like, I only care about this particular service in these particular hours, like business hours, I want this particular notification media. I want to be SMS'd for criticals, and I only want emails for warnings, that sort of thing. We're trying to build a very customizable framework so you can go and make those customizations in your site. And dampening as well, and that's what I was talking before about how if 1,000 or several thousands of things fail simultaneously, not sending out hundreds of alerts. We've got a built-in tagging system behind the scenes that we've done a lot of work on that we haven't exposed yet particularly well, but it is going to form the core of this dampening or roll-up thing. So trying to limit and identify the root causes a bit more easily through metadata. So to go over what I just said again, we've got a new focus on event processing. It's Redis backed. All these reasons why you should totally come and start using it. We actually have a Vagrant appliance that you can start testing. That's going to be open source this week. Thank you. Any questions?
Just very quickly, Googling here. The notice about Nagios versions, is it going to get fixed? Will you work with the current versions in the near future?
There is an intention to use to support the newer versions. Right now, it's sort of just what we're stuck with in production. But yeah, there's some fundamental limitations in the way that event data is emitted from Nagios that makes it a bit complicated. But it's not an intractable problem by the stretch of the imagination. Yes?
When you're talking about thousands of alerts and not swamping the admin, is that through just rate limiting, or is it doing some sort of clever dependency working out?
Yeah, that's a really good question. So I glazed over that a tiny bit, but the gist of it is that rather than trying to represent your architecture or your infrastructure as a big hierarchy of things that are related to one another, you just tag everything as much as possible. So you put as many descriptive tags as possible. And we have triggers that are set up on counters for each tag. So it's like 80% of the things that are tagged with ESX, for example, are firing. And there's this thing here that's tagged over as being a network switch, but also share some of the same tags. Present that information in a usable and actionable way, so that you don't have to focus on building up a complex and forever changing hierarchy. And you can focus more on actually responding to incidents. Any more questions? All right, thank you very much.